Welcome back to Knowledge Academy's YouTube channel. In today's video, we're going to compare two of the most fundamental techniques in data science: linear regression and logistic regression. While they might sound similar, they serve different purposes and are used in distinct scenarios. By the end of this video, you'll have a clear understanding of how these models differ across various parameters and when to use each one. So let's get started. Let's start by comparing the purpose of each model. The primary purpose of linear regression is to predict a continuous outcome. This means it's used when you're trying to forecast a specific numerical value based on one or more input variables. For example, predicting the price of a house based on its size, location, and number of rooms. Whereas in contrast, logistic regression is designed for classification tasks, where the goal is to predict a categorical outcome, typically binary. For example, predicting whether an email is spam, which means 1 in binary, or not spam as 0 based on its content. Next, let's compare the type of output that each model produces. The output of a linear regression model is a continuous numerical value, which can theoretically range from negative to positive infinity. For example, if you input the size of a house into a linear regression model, it might output a price of $250,000. Whereas logistic regression, on the other hand, outputs a probability that a given input belongs to a particular class. This probability is then converted into a binary outcome that is 0 or 1. For example, for an email classification task, logistic regression might output a 0.8 probability of the email being spam. If the threshold is set at 0.5, the final output will be one that means it is spam. Now let's talk about the assumptions each model makes, particularly regarding linearity. Linear regression assumes a linear relationship between the input variables that is independent variables and the output variable that is dependent variable. This means that as the input changes, the output changes in a straight line. For example, if doubling the size of a house typically doubles the price, this linear relationship can be captured well by linear regression. Whereas in logistic regression doesn't assume a linear relationship between inputs and outputs. Instead, it assumes that the log odds of the outcome is linearly related to the input variables. This makes logistic regression well suited for scenarios where the relationship between variables is not linear. For example, the relationship between the likelihood of clicking a link and the time of day might not be linear, but logistic regression can still model the probability effectively. Let's compare the error distribution in both models. Linear regression assumes that the residuals, that is, the differences between the observed and predicted values, are normally distributed. This assumption is crucial for making accurate predictions and reliable confidence intervals. For example, when predicting house prices, the difference between the actual and predicted prices should ideally follow a bell curve distribution. Whereas in logistic regression assumes that the errors are abnormally distributed since the outcome is binary. This makes it suitable for situations where the output is a probability or a categorical result. For example, in a spam detection model, the errors are the number of misclassified emails, which naturally follow a binomial distribution. Another key aspect to compare is model interpretability. Linear regression is often praised for its simplicity and ease of interpretation. Each coefficient represents the expected change in the output variable for a one-unit change in the input variable. For example, in a model predicting house prices, a coefficient of 50,000 for the size variable means that for each additional square foot, the price increases by $50,000. While logistic regression is also interpretable, the coefficients represent the change in the log odds of the outcome for a one-unit change in the input. This can be less intuitive, as it requires understanding odds and log transformations. For example, a coefficient might show that each additional email in a certain category increases the odds of an email being spam by a factor of 2. Finally, let's look at some common use cases for each model. Linear regression model is widely used in financial forecasting, pricing models, and any scenario where you need to predict a specific number. For example, predicting future sales based on historical data, whereas logistic regression shines in scenarios where you need to classify items into categories. It's commonly used in medical diagnosis, fraud detection, and marketing. For example, predicting whether a transaction is fraudulent or whether a patient has a particular disease based on their symptoms. So, there you have it, a detailed comparison between linear regression and logistic regression across various parameters. Now, in the next video of this machine learning series, we will learn about WN classification with a real-life example. I hope this video helped clarify the differences between these two powerful models. If you found this video helpful, make sure to like, subscribe, and hit the bell icon so you never miss an update.